Hello science enthusiasts and welcome back to the channel. I'm Shireen Brad and today get ready to be amazed. Welcome to our exploration of common elements and everyday objects. That's right, we're going on an elemental adventure, uncovering the secret science ingredients hidden in plain sight all around us, in the things we use every single day. From the moment you wake up to the moment you go to sleep, you're interacting with these fundamental building blocks of the universe. It's going to be quite a journey, so buckle up. Now, what exactly are these elements we're talking about? Well, elements are pure substances made of only one type of atom and are the building blocks of everything around us. Think of them as the ultimate Lego bricks of the cosmos. Each element has its own unique properties, its own special personality, if you will, and when these elements combine, they form all the amazing and diverse materials we see and interact with. From the air we breathe to the gadgets we can't live without, elements are the unsung heroes working tirelessly behind the scenes. So, are you ready to become an element detective? Fantastic. Let's dive into some of the most common elements and see where we encounter them in our daily lives. We'll explore their cool properties, their surprising uses, and how they make our modern world possible. We're going to look at everything from your breakfast table to the stars above. Well, maybe not the stars today, but definitely things just as fascinating right here on Earth. Prepare to have your mind expanded. All right, let's kick things off with a truly versatile element. Carbon, symbol C, atomic number 6. Now, when you think of carbon, what comes to mind? Diamonds? Coal? Well, how about that trusty pencil you use to jot down your brilliant ideas? Surprise! The lead in pencils isn't actually lead at all. It's graphite, which is a very special form of carbon. Yes, the same element that forms dazzling diamonds also helps you write your shopping list. Consider this. Graphite is made of layers of carbon atoms, and these layers can slide past each other, which is why it leaves a mark on paper. Science is everywhere, but carbon's talents don't stop at writing. Oh no, carbon is the backbone of life itself, and it's a superstar in the world of materials. Take plastics, for example. So many of the plastics we use every day, like polyethylene in your milk jugs or water bottles, and polystyrene in your disposable cups or food containers, are organic compounds. And what does organic mean in chemistry? It means they contain carbon. Carbon atoms can link together to form long chains and complex structures, creating an incredible variety of materials with different properties. It's truly the king of connections. Next up, an element you absolutely cannot live without, oxygen, represented by the symbol O, atomic number 8. Every breath you take, every single one, delivers life-giving oxygen to your body. Our atmosphere, this wonderful blanket of gas surrounding our planet, is about 21% oxygen. This isn't just important for us humans and animals to breathe. Oxygen is also crucial for combustion. That means fire. From the tiny flame of a candle to the roaring engine of a rocket, oxygen plays a key role in making things burn by reacting with fuel. It's a highly reactive element, always ready for action. And where else do we find this amazing element? Well, take a sip of water, H2O. That O stands for oxygen. Water, essential for all known forms of life, is made up of 2 hydrogen atoms bonded to 1 oxygen atom. So every time you're enjoying a refreshing glass of water, or any beverage for that matter, you're interacting with oxygen in its combined state. It's in the oceans, the rivers, the clouds, and even in you. Oxygen is truly fundamental, a cornerstone element for life as we know it on this beautiful blue planet. It's simply breathtaking. Let's move on to a metal that's incredibly common in our modern lives. Aluminium, or aluminum, depending on where you are. Symbol Al, atomic number 13. This element is a real champion when it comes to being lightweight yet surprisingly strong. Think about those soft drink cans you recycle. Many of them are made from aluminium. It's easy to shape, doesn't rust easily like iron, and can be recycled over and over again, which is fantastic for our planet. So next time you pop open a can, give a little nod to the amazing aluminium making it possible. But aluminium's usefulness doesn't stop with beverages. Oh no, this element is a kitchen superstar. Ever used aluminium foil for cooking or storing leftovers? That's our friend Al at work again. Thin and flexible, great for wrapping things up. And many of your pots and pans might be made from aluminium too. Why? Because it has excellent heat conduction. This means it spreads heat quickly and evenly, helping your food cook perfectly. From protecting your food to helping you cook it, aluminium is a lightweight hero with a heavyweight impact on our daily routines. Now let's talk about an element with some serious strength, iron, symbol Fe, from the Latin word ferrum, atomic number 26. Iron has been a cornerstone of human civilization for thousands of years, and for good reason. It's strong, it's abundant, and it's incredibly versatile. In your kitchen, you might find it in the form of heavy-duty cast-iron skillets or Dutch ovens. These cooking utensils are prized for their ability to retain and distribute heat evenly. Perfect for searing a steak or baking a loaf of bread, they can last for generations. But iron's biggest role is arguably in construction. When iron is alloyed with carbon and other elements, it forms steel. And steel, well, steel is literally the backbone of our modern world. It's used to build skyscrapers that pierce the clouds, massive bridges that span vast rivers, and the railways that connect our cities. Its strength and durability make it indispensable for creating the infrastructure we rely on every single day. So, from your trusty frying pan to the towering buildings in your city, iron is there, providing strength and support. It's truly monumental. Let's shine a light on another fantastic metal, copper, symbol Q from the Latin cuprum, atomic number 29. Copper is one of the first metals ever used by humans, and it's still incredibly important today, especially when it comes to electricity. Have you ever wondered what's inside those electrical cables that power your lamps, your computer, your television? There's a very good chance it's copper. Copper is an excellent conductor of electricity, meaning it allows electrical current to flow through it very easily. This property makes it essential for wiring in our homes, our gadgets, and our entire power grid. Beyond electricity, copper also plays a vital role in plumbing. Many homes and buildings use copper pipes to carry their water supply. Why copper? Well, it's durable, it resists corrosion, meaning it doesn't easily break down or rust away when exposed to water. And it even has antimicrobial properties, which can help keep water clean. So, copper is not just conducting electricity to power our lives, it's also safely delivering the water we need. It's a hard-working element, making modern conveniences possible from the inside out. Consider the current flow of information and energy thanks to copper. Time to talk about an element that's powering the digital age. Silicon, symbol C, atomic number 14. Now, silicon is a metalloid, meaning it has properties of both metals and non-metals. And its most famous application? Computer chips. That's right, the microprocessors and integrated circuits that are the brains inside your smartphone, your laptop, your gaming console. They're made primarily from highly purified silicon. Silicon's unique electrical properties as a semiconductor allow it to control the flow of electricity in incredibly precise ways, making all our amazing digital technology possible. It's the silent hero of the information age. But silicon isn't just about high-tech electronics. Look around you, see any glass, perhaps a window, a drinking glass, or the screen you're watching this on? Well, the main ingredient in most types of glass is silicon dioxide, which is a compound of silicon and oxygen. And where does silicon dioxide come from? Sand. That's right, common beach sand is mostly silicon dioxide. So from the sandy shores to the super-fast processors in your pocket, silicon is an element that shapes our world in both transparent and incredibly complex ways. It's a real transformer. Now for an element that has captivated humanity for millennia, gold. Symbol Au from the Latin aurum, meaning shining dawn, atomic number 79. Gold is famous for its beautiful, lustrous yellow color, its rarity, and its resistance to tarnishing. This makes it highly prized for jewelry, rings, necklaces, bracelets, earrings. Gold has been used to create stunning decorative items and symbols of wealth and status for centuries. It doesn't corrode or react with most other chemicals, so its shine truly lasts. It's a timeless classic in the world of elements. But gold isn't just about looking pretty. Its amazing properties also make it incredibly useful in technology, particularly electronics, because gold is an excellent conductor of electricity and highly resistant to corrosion. It's used in high-quality connectors, switch contacts, and circuit boards in sophisticated electronic devices. Think about the crucial connections inside your computer or smartphone that need to be reliable for years. Gold often plays a part there. So this precious metal is not only a symbol of beauty and value, but also a critical component in ensuring our technology works flawlessly. Pure gold performance. Let's shake things up with our next element. Sodium, symbol Na, from the Latin natrium, atomic number 11. When you hear sodium, what's the first thing that pops into your head? Probably table salt. And you'd be right, table salt is sodium chloride, NaCl, a compound of sodium and chlorine. It's essential for flavoring our food, preserving it, and it even plays a crucial role in how our nerves and muscles function. So that pinch of salt is doing more than just making your fries taste good. It's vital for your body, in the right amounts, of course. But sodium's talents extend beyond the salt shaker. Ever used baking soda in your kitchen? That's sodium bicarbonate. It's a fantastic leavening agent, helping your cakes and cookies rise and become fluffy. And it's also a great cleaning agent, useful for scrubbing surfaces or deodorizing your fridge. Sodium compounds are also used in things like streetlights. Those bright yellow-orange ones are often sodium vapor lamps. Sodium is a highly reactive alkali metal, so you won't find it in its pure form in nature, but its compounds are incredibly useful and widespread. It's an elementary part of our kitchens and cities. Now, let's dive into an element that's a powerhouse of cleanliness. Chlorine, symbol Cl, atomic number 17. Chlorine is a halogen and it's a highly reactive non-metal. You're probably most familiar with its work as a disinfectant. Many household cleaners, especially bleach, contain chlorine compounds. These compounds are incredibly effective at killing bacteria, viruses, and other harmful microorganisms, helping to keep our homes sanitary and safe. It's the unseen guardian against germs, working hard to protect us. Think about that powerful cleaning action. Another place where chlorine plays a crucial role is in our swimming pools. Chlorine is commonly added to pool water to sanitize it, killing off any nasty bugs and keeping the water safe and clear for swimming. It's what gives pools that characteristic clean smell. Beyond disinfection, chlorine is also vital in producing many plastics like PVC, polyvinyl chloride, which is used for pipes, window frames, and so much more. So from sparkling clean kitchens to refreshing dips in the pool, chlorine is an element that helps maintain hygiene and build our surroundings. It's clearly important. Let's talk about an element that's essential for strong structures both in our bodies and in the world around us. Calcium, symbol K, atomic number 20. When you think calcium, you probably think strong bones and teeth, and you're absolutely right. Dairy products like milk, cheese, and yogurt are famously rich sources of calcium. Our bodies use calcium to build and maintain healthy bones and teeth. And it also plays a vital role in muscle function, nerve transmission, and blood clotting. It's a true body builder at the elemental level. Many people also take calcium supplements to ensure they're getting enough of this crucial mineral, especially for bone health as they age. But calcium isn't just in our food and supplements. It's a major component of materials like limestone, marble, and chalk, all forms of calcium carbonate. These materials are used in construction, for making statues, and even for writing on blackboards. Cement and concrete also rely on calcium compounds. So from the skeleton inside you to the buildings around you, calcium is providing strength and structure. It's fundamentally strong. Our final element for today is a real heavy hitter with an incredibly high melting point, tungsten, symbol W, from its German name Wolfram, atomic number 74. Tungsten is a remarkable metal known for its incredible toughness and its ability to withstand extremely high temperatures. In fact, it has the highest melting point of all known metallic elements, a staggering 3,422 degrees Celsius or 6,192 degrees Fahrenheit. That's incredibly hot. This extreme heat resistance makes it perfect for some very specific and important jobs. The most classic example of tungsten at work is in the filaments of old-school incandescent light bulbs. That tiny coiled wire inside the bulb that glows brightly when electricity passes through it. That's often made of tungsten. It can get white hot without melting, producing light for us to see by. While incandescent bulbs are becoming less common, tungsten is still used in many high-temperature applications like rocket nozzles, heating elements in furnaces, and even in welding electrodes. It's a truly resilient element, shining under pressure and the extreme heat. What a way to glow. What a way to... And there you have it: carbon, oxygen, aluminium, iron, copper, silicon, gold, sodium, chlorine, calcium, and tungsten. We've journeyed through just a handful of the amazing elements that make up our world. These common elements are all around us, playing crucial roles in our everyday lives, from the mundane to the magnificent. It's truly awe-inspiring when you stop and think about how these fundamental particles combine to create the complexity and wonder we see everywhere. Science is pretty cool, isn't it? Next time you use a pencil to sketch an idea, take a refreshing drink of water, admire a piece of jewelry, or simply turn on a light to read your favorite science book, take a moment. Remember the amazing elements that make it all possible. Each object tells a story of chemistry, a story of the periodic table in action. Recognizing these connections can bring a whole new layer of appreciation for the ordinary things we often take for granted. It's all interconnected, all based on these incredible building blocks. Thank you so much for joining me, Shireen Brad, on this elemental expedition. I hope you've learned something new and feel a little more connected to the amazing science that surrounds us. Don't forget to like, subscribe, and hit that notification bell so you don't miss our next adventure. Thanks for watching, and as always, stay curious. There's a whole universe of discovery out there waiting for you to explore it. Keep asking questions.